Right. Hello everyone, my name is Roberto and as my senior project I'm designing the drivetrain and chassis of a 1-inch Scalar City with my partner Rogelio, who is designing the steering wheel suspension. Now to start off, during the fall quarter and initial design of the device, the intent was to use additive manufacturing as much as possible, and so 3D printing was the manufacturing that was mainly utilized throughout the manufacturing of the device, which was using the 3D printers provided by the project team members, which not only allowed for the team to further reduce the weight of the device, since the material that was going to be used was a plastic called PLA+, which was less dense than other materials like, say, aluminum or steel, but it was also very possible to further reduce the manufacturing costs, since there wasn't going to be a need to have any components outsourced, as well as it was very possible to have everything manufactured in-house. Now, as for the construction and manufacturing of the device, there were 4 major sub-assemblies, which can be seen here in the drawing sheet, where the 4 assemblies were the chassis subassembly, the front and rear suspension subassemblies, and then the drivetrain subassembly. And during the manufacturing of the components for these various subassemblies, there were some issues that occurred, like with the axle here in the drivetrain subassembly. The initially manufactured axle was not entirely concentric throughout its length, which was due to the tailstock not being engaged on the lathe during the manufacturing process. And the issue with this was, since the axle extruded a decent amount from the bias of the lathe, and without the support of the tailstock, once the bit was engaged and was removing material, it would also be slightly pushing the axle out, and thus it was causing it to become unconcentric. However, once this issue was mitigated by engaging the tailstock, it was very possible to then manufacture the axle, which can be seen here, without any further issues. And during the assembly of the manufactured components, there were also some issues that were noted, like the spur gear slipping on its axle, which would be right here, and one of the bevel gears not sitting completely flush inside of the gearbox. So in order to prevent the spur gear from slipping, a threaded insert was inserted to the hub of the gear so that a metal set screw could be used. However, there wasn't a lot of material for the insert to really grab onto, and so a hole was drilled through the axle where the gear was going to be fastened, so that the set screw could fasten all the way through the gear, thus preventing the spur gear from slipping. As for the bevel gear not sitting completely flush, the way that this was mitigated was by adding a shaft collar to the shaft. However, since the team was getting close to the deadlines of presentation, it wasn't really possible to order a shaft collar with the correct dimensions, and so a shaft collar was designed and then 3D printed using the dimensions of the shaft where the bevel was going to be fastened, as well as ensuring that there was going to be a slot for the spur key to fit in. And then with the addition of a threaded insert, it was possible to use the shaft collar to keep the bevel gear completely fastened, having it sit flush inside of the gearbox, as well as preventing it from slipping out when the gears were going to be operated. So now moving on to the time and cost of the project. The current expenditure of the device is $690, which was $190 greater than the initially estimated amount of $500, and the main reason for this is due to the knuckles that were purchased, which can be seen here at $86. And the issue with the knuckles was that they required a very specific set of axle ends as well as hardware, which were sold separately and were a bit expensive themselves. And then with the addition of the wheels as well as the other electronic components like the ESC and the servo, then the total cost for the purchase components was $607 right here. And while the manufacturing cost was only $82, which can be seen right here. And this was the area where the team saved the most amount of money, as was initially intended when the manufacturing process was selected. But to further reduce the cost of the device, it would be an alternative would be looked into when purchasing the knuckles, so that they wouldn't be as restrictive as the ones that are currently being used, so that a different set of hardware could be purchased and it wouldn't be as expensive. Now, schedule-wise, here is the winter schedule where the manufacturing and the assembly of the device was documented. However, there wasn't any catastrophic failures that really caused the project to become delayed. But there were a few hiccups during the assembly and manufacturing of some of the components, like with the axle, but they were remedied for the next deadline to ensure that the project wasn't going to be falling behind. And so today we currently have the fully assembled device where the drivetrain was designed to be a speed reducer, having a train value of 12 to 1 and ensuring that the vehicle can achieve a velocity of 30 miles an hour. Thank you.